In this video, we are going to be talking about transformations of quadratic equations in vertex form. Now, remember that the parent function for a quadratic function is y equals x squared. So when we are talking about the different transformations today, we are going to be comparing that to this function, y equals x squared, which is graphed on my calculator here. So when we are looking at our equation in vertex form, this is the equation f of x equals a times x minus h squared plus k. So there are four places that you want to go ahead and look here when your equation is in vertex form. First, we want to actually go ahead and look at the value in front of a. So if a is negative, which means a is less than 0, then the graph will reflect across the x-axis. So basically, guys, what that means is your graph opens down. And if the value of a is positive, guys, there is no reflection, and that means that your graph opens up. Then we want to actually go ahead and look at the value of a. So if a is greater than 1, then we call that a vertical stretch. And what that looks like is your graph becomes narrower. So an example of that may be something like 2x squared. So just to show you what a vertical stretch or becoming more narrow looks like, I'm going to go ahead and press tab, and I'm going to go ahead and type in 2x squared. Here the value of a is 2. Again, that's greater than 1. And when I press enter, you're going to see that it is more narrow than my parent function, which is the blue parabola here. So again, we call that a vertical stretch. Now, if a is less than 1, your graph will be vertically, this is called a vertical compression. And what I like to think of when, or tell me remember that it is a vertical compression, I like to think of the phrase less compress. So less has that ESS in it, and so does compression. And to help me remember what a compression does, I like to think of the fact that it says press in compression, and that helps me remember that I need to press down on something. And when I'm pressing down on something, it's getting wider. So that would be another way to explain a vertical compression, is that your graph is getting wider. So an example of that would be something like 1/2 x squared. So if I press tab to show you this in the calculator, I'm going to go ahead and press control divide, 1 on top, 2 on the bottom, and then x squared. Oops, sorry, did that wrong. You will see that it gets wider than the parent function, which remember is the blue parabola. So then the next place you want to check is inside of the parentheses. You want to look at the value of h. Now, guys, here, when it comes to h, you always want to think the opposite here. So I'm going to star that. So the h affects the horizontal shift of your graph. So remember, horizontal means that we are moving left or right. And again, remember, like I said, we always want to think the opposite. So here, if f of x equals x minus 5 squared, then the value of h equals 5. Again, we are thinking opposite. So let's see how that this affects our parent function and its transformation. So I'm going to go ahead and open up a brand new graph, and I'm going to type in the parent function x squared. And then I'm going to type in x minus 5 squared right after that by pressing the down arrow. Now, when you compare this function to our parent function, you're going to notice that this is going to shift 5 units to the right. So again, here's what I mean by you have to think the opposite. Typically, our brains are wired to think that if we see the minus sign here, we have to go left. But when it comes to the quadratic equation in vertex form equation, we have to go the opposite. We have to go to the right. Now, this is going to also be the same for the next problem. Again, we want to think opposite. So it says if f of x equals x plus 4 squared, then h equals, well, the opposite of positive 4 is negative 4. And your parent function will shift 4 units to the left. So again, you are thinking the opposite here. So if I plug that equation into my calculator, I'm going to press, tab, and then parentheses x plus 4 squared. you will see that my graph shifts 4 units to the left from my parent function. So again, our brains need to think that if we see the minus sign, we are going to the right, and if we see the plus sign, we are going to the left. Now, the last spot we want to go ahead and look at is the value of k. Now, there are no tricks with k. So the k affects the vertical shift of your graph. So here we are either going up or down. If we go up, if you have a plus sign, we're going up, and if we see a minus sign, we are going down. So if f of x equals x squared minus 5, then k equals negative 5. Again, there are no tricks here. What you see is what you get. And your parent function will shift 5 units down. F of x equals x squared plus 4, then k equals, again, there are no tricks, so this is k equals 4. And your parent function will shift 4 units up. So again, looking at our equation in vertex form, there again are 4 locations you want to look. First is in front of the value of a. If it's positive, your graph opens up. But if this is negative, this means that your graph reflects across the x-axis and that your graph opens down. The value of a, if it's greater than 1, we call that a stretch. Your graph gets more narrow. If it's less than 1, that is a compression. Your graph gets wider. Then we want to look inside of the parentheses at h. This affects the horizontal shift of your graph. Again, think opposite. So if we see a minus sign, we're going to the right. If we see a plus sign, we're going to the left. Then we want to look at the vertical shift. Again, there are no tricks here. So if you see a plus sign, you're going up. If you see a minus sign, you're going down. Now, the vertex form equation also tells you a couple different things. Again, in the name, you see the word vertex. So the vertex form of a parabola in vertex form will always be h, comma, k. So when we want to pull the vertex out of the equation, again, I'm going to go ahead and look at h, and I want to think the opposite of that value, and then k will stay the same. Now, what this also can tell you is your axis of symmetry. Remember that your vertex is x, it's still an ordered pair. Again, and all ordered pairs have an x and y value. So here, guys, all h is the value of x. So when I'm trying to write out the equation for my axis of symmetry, when my equation is in vertex form, I just, or the equation will be x equals h. So x equals, I'll come to look at the inside of the parentheses, and I'll write down the opposite number of that. So let's go ahead and open up our notes, and let's go ahead and continue to look further at transformations here. So here it says determine the parameter changes on the quadratic graphs given compared to our parent function y equals x squared. So when I look at number 1, we have y equals 2 times x minus 4 squared plus 6. So again, there are 4 places that we want to go ahead and look at when it comes to determining the different types of transformations that are occurring. So again, first we want to go ahead and look at in front of a. And here a is positive. So that means that there would be no reflection. Then we want to look at the value of a. In this case, the value of a is 2. And so since the value of a is 2, what that tells us is that this is a vertical stretch. My graph will become more narrow. Then we want to look inside of the parentheses. And remember, we always want to think opposite here. Again, this is a horizontal shift. So here, this is a horizontal shift. I see a minus sign. My brain wants me to think going to the left, but we have to think the opposite. So we are going to the right by 4 units. Lastly, we want to look at the value of k. So here I'm going up or down. Remember, there are no tricks. So for my vertical shift here, I am going up by 6 units. Now, the last thing that I want to identify is the vertex of my graph. So again, this is h, comma, k. So my h values inside of the parentheses. I see here that I have an x minus 4. Again, remember, think opposite. So the value of h is a positive 4, comma, 6. Next up, let's look at number 2. Number 2, we have y equals negative 1 over 2 times x plus 2 squared minus 5. So the first thing that it wants us to check for is a reflection. So this, I'm looking at the sign in front of a. So here I have a negative value. So that negative value tells me, yes, there will be a reflection. So I'm going to go ahead and write reflection. Then I want to actually go ahead and look at the value of A. Now here the value of A is 1/2, and 1/2 is less than 1. So remember that phrase, less means compress. So this is a vertical compression. Next up, we want to look inside of the parentheses. And again, remember this is a horizontal shift. So number 3 is a horizontal shift. I'm going to put HS for horizontal shift. And here I see that I'm moving by 2 units. I have a +2. My brain wants me to say I should be going right 2, but I have to think the opposite. So I would be going left by 2 units. So I'm going to go ahead and say left 2 units. Lastly, I want to look at the value of K. And remember, there are no tricks with K. This, again, is my vertical shift. I'm going to go ahead and put VS for vertical shift. And because I see that I have a -5, remember that means I'm going down 5 units. Next up, let's go ahead and take a look at number 3. Number 3, we have y equals x plus 3 squared plus 12. So again, there are 4 things we want to check out. So number 1, again, I want to look at the value of A. Well, here, since there's technically nothing in front of my set of parentheses, remember that means that the value of A is equal to 1. So it is positive. So that means there is no reflection. I'm going to put, no reflection. Now, guys, if my value of A is 1, remember, if something is 1, anytime I multiply or divide something by 1, it stays the same. So I'm going to go ahead and write stays the same here because nothing is happening to this graph in terms of its width. It's not being compressed and it's not being stretched. So again, we're going to put stays the same. The third place we want to check for is inside of the parentheses. So again, remember, this is our horizontal shift. So remember, we want to think the opposite here. So here I see that I am adding 3. My brain wants me to think I should be going right 3, but I'm going the opposite. I'm going to go left 3 units. The last place we want to go ahead and check for is the value of K. Now here I am adding 12. And so again, this is a vertical shift. If I'm adding 12, this means I'm going up 12 units. Now, the last thing we want to go ahead and identify is our vertex. So coming here to the value of h, remember I want to think the opposite. So if I have x plus 3 here, then the value of h is actually -3. And then remember, there are no tricks with k. So here, my k value is a +12. So my vertex is -3, 12. Now, I'm just realizing that we forgot to find our vertex on number 2. So let's go ahead and do that real quick. Again, coming over to the value of h here, again, think opposite. So my value of h is a -2. And then there are no tricks with k. So my k value is a -5. Okay, lastly, let's go ahead and look at number 4. Number 4, we have y equals 1/4 times x minus 2 squared minus 3. So again, there are 4 things we want to check for here. So first, I want to know, is there a reflection? So again, remember, I look in front of my value for A. And since this is positive, that means that there is no reflection. Next, I want to look at the value of A. So the value of A here is 1/4. Again, that is less than 1. So remember, less means compress. So this would be a vertical compression. Next, we want to look inside of the parentheses. Remember, always think opposite. Remember, inside of the parentheses is a horizontal shift. So here, I'm either going left or right. Again, remember, always think opposite. So if I see a -2, then that means I must be going right by 2 units. Lastly, I want to look at the value of K. This is a vertical shift. Here I have a -3, so that means I'm going down by 3 units. Lastly, let's go ahead and find our vertex. So again, remember our vertex is h, k. First thing I want to go ahead and do is find the value of h. So I'm coming inside of the parentheses. Here, my h value, remember, is the opposite of what I see. So my h value is a +2. And the value of k is a -3. So here my vertex is 2, -3. Let's go ahead and keep moving on. Number 5, the graph f of x was transformed to create the graph m of x. So f of x is our parent function. Remember, this is always what we will compare it to. Again, this is f of x equals x squared. So which equation could represent the graph of m of x? So guys, when you are determining what type of function is going on, you have to think to yourself, okay, is my graph becoming more narrow? Is it getting wider? Is it being vertically shifted or horizontally shifted? Now, when I look at my parent function compared to m of x, I notice that my graph has been shifted down. So I am shifting down. And so I know that that means that it represents the value of k. So this would, for instance, be f of x plus the value of k. That's what I am looking for. And so here I see that my graph has been shifted down by 7 units. Well, if I am shifting down 7 units, remember that means I'm subtracting. So this function ends up becoming f of x minus 7. So here my answer is C. Again, guys, what we are trying to represent is what is happening to our parent function. And our parent function is, again, f of x. And since it's been shifted down 7 units, I know that that should be outside of the parentheses. So that is why I have this minus 7. If it's inside the parentheses, remember that means your graph shifts horizontally. So it moves left to right. But again, your answer here is C. Okay, number 6. The parent function f of x equals x squared was translated to create g of x as shown on the grid. If g of x equals f of x plus d, find the value of d. So again, remember here that your parent function is f of x equals x squared. If you need to see what your parent function looks like, you can press x squared, press Control T, and what you're going to want to go ahead and do is graph your points on your graph if you need to visually see that. So here I have the point negative 3, 9. We have negative 2, 4. Negative 1, 1. 0, 0. 1, 1. 2, 4. And then 3, 9. So from here, we can go ahead and connect the dots. Now, guys, really, when it comes to transforming your parent function, what you need to really look at, pay attention to is your vertex. So here I see that my vertex on my parent function is at the origin, and I see here that g of x has been shifted down by, this time, 9 units. So we know that a vertical shift is the value of k. And again, in this case, we're talking about f of x plus d. So I need to replace d. Basically, guys, here, d is serving as your y-intercept. So in this case here, my y-intercept happens to be 9. So this would be f of x minus 9. This would be my answer, f of x minus 9. Okay, next up, the parent function was transformed to create a of x as shown on the graph. Which equation could represent a of x? So again, guys, remember we are comparing this to our parent function, which again, I can write out these points for you that are on the last graph as well, or just remember that your vertex is at the origin. Now here, remember my vertex is at the origin, and on a of x, it has now shifted to the left by 3. Well, guys, if I'm shifting vertically, remember, vertical shifts happen inside of the parentheses. So that can be represented by x minus h squared. So in this case, I have shifted left 3. My x value is at negative 3 here. So what I can basically do is I can say x minus negative 3 squared. And basically, guys, what happens here is we see a double negative, so we know we have to add. And so here, this is x plus 3 squared. So my answer, again, is D. So you could have also remembered that if I'm going left 3, I want to say minus 3, but I have to think the opposite, so that's plus 3. But again, I showed you the explanation as to why it's a plus sign here. Moving on to our next problem, we have number 8. The graph of f of x equals x squared was transformed to create r of x. if r of x equals n f of x, which of the following is a possible value for n? So guys, here, if the value that we are trying to find is in front of n, this is our value of a. We are trying to determine if the width of my graph has been affected. So remember, if the value of a is greater than 1, that stands for a vertical stretch. If it's less than 1, it's a vertical compression. So here's my parent function f of x. Here we then have r of x. We notice that my graph has gotten wider. So remember, if it's getting wider, that is a vertical compression. Remember, less means compress. I know that the value of a has to be less than 1. So looking at my answer choices, 3 is obviously less than 1. If I look at converting my fractions, 4 over 3 as a decimal is going to give me 1.3 repeating. So that is less than 1. And then guys, some of you get stuck between 1 over 3 and negative 4, because technically negative 4 is less than 1, but you want to think of this as two separate things. When it comes to negative 4, 1, because it's negative, this is showing that it is a reflection, and then you want to think of the number 4 as itself, and 4 is greater than 1. So this represents a vertical stretch across the x-axis. So here my answer is C. This is the only one that is less than 1, which is 1/3. Okay, number 9. Given the graph of f of x and g of x, how do the graphs compare? So first thing I automatically notice is that my graph is reflected. It is reflected across the x-axis, and I know it's reflected because it opens down. Now, when I'm comparing the overall size to the parent function, I notice that g of x looks like it has gotten wider. And remember, when it gets wider, we call that a vertical compression. So I'm going to say compression / wider. Now, the last thing I also notice is that this graph has been shifted down 1 unit. So down 1. So looking at my answer choices, I am looking for the function that says it has been shifted 1 unit down and gotten wider. So I can obviously eliminate A and C because it says above. And then my graph has gotten wider, so my answer is D. So that is your notes. Make sure you go ahead and glue this into your journal. Now, the last thing I want to go ahead and go over with you is your assignment. So let's go ahead and look at a problem on your assignment so you know what I expect for this to look like. So numbers 1 through 6, it says determine the parameter changes on the quadratic graphs given compared to the parent function y equals x squared. Let's go ahead and check out number 4. So number 4, we have y equals 1/2 times x minus 4 squared minus 3. Now guys, I want you to kind of think of number 1 as of these bullet points. I want you to think of as your template for the questions that you have to answer. So there are 4 things that we want to answer, plus I want you to provide your vertex. And if you provide your vertex, I will give you extra points. So again, first thing you want to check for is if your graph, if your a value is negative or not. So here we have y equals negative 1/2 times x minus 4 squared minus 3. Well, the value of a here is negative, so this means that it is a reflection. So I'm going to go ahead and write reflection. Second thing I want to go ahead and check out is actually the value of a. So the value of a itself is 1/2, and 1/2 is less than 1. Remember, less means compress. So this is a vertical compression. Okay. Next, I want to check for my horizontal shift. So remember, that means I'm either moving left or right. And again, you always want to think the opposite. Remember, horizontal shifts happen inside of the parentheses. So looking inside the parentheses, I have x minus 4. Remember, my brain wants me to say minus. I want to go left, but I have to think the opposite. So I'm actually going right 4. And then lastly, I want to look at the value of k. Remember, there are no tricks with k. This is a vertical shift. And if I am subtracting 3, that means I'm going down 3. Now, the last thing I want to check for is my vertex. Remember, your vertex is h, k. And we want to think, again, the opposite when we are identifying the value of h. So coming over to look inside the parentheses, I see here that I have x minus 4. Remember, your value for h is the opposite. So here, my h value is 4. The value for k is -3. Remember, there are no tricks here. And here, my coordinate is 4, -3 for my vertex. So these are the things that I am looking for when it comes to identifying the different parameter changes. Guys, if the value of a is positive, you do not have to include number 1. You don't have to write no reflection. You don't have to write anything for number 1. For number 2, if there is nothing in front, so for instance on number 2, here we have a value of a of 1. Here for number 2, it's not a vertical compression or a stretch. So you would just write, let me go ahead and put number 1, I would just put nothing. Number 2, since it's 1, I know that that would stay the same. And then you would just have to identify the vertical shift and the horizontal shift for 3 and 4. But again, use number 1 as your kind of template for the 4 things that I want to see on your paper in this section. Okay, and then number 7, 8, 9, and 10, these are all just kind of making sure that you're understanding the different type of shifts between what it looks like. So for instance, we can look at number 7. The answer choice describes how the graph of f of x equals x squared was transformed to create the graph of n of x equals x squared minus 4. Well, guys, this transformation is occurring outside of the parentheses. So when it happens outside of the parentheses, we know that's a vertical shift. Remember, there are no tricks when it comes to a vertical shift. So I can cross out B and D. Now, I see that I am subtracting 4. And if I'm subtracting 4, that means I am going down. So this is a vertical shift down. Let's also take a look at number 9. The graph of f of x equals x squared was transformed to create the graph of g of x equals x minus 8.5 squared. Which of these describes this transformation? So guys, if your value is inside of parentheses, remember this is a horizontal shift. So anything that says vertical shift, I'm going to go ahead and eliminate. And remember, we always want to think the opposite. So if I see a minus sign inside of the parentheses, remember that means I'm actually going right. So here my answer is A. From here, you can go ahead and finish up the rest of your assignment. Guys, when you take a look at number 14, remember, basically all you have to do on this problem is identify your vertex. On this problem, if I have x minus 5, remember that means I'm going right 5. And then plus 1 means I'm going up 1. So which one has a vertex that is right 5 and up 1 from the origin? So again, that was this video covering transformations of quadratic equations. If you have any questions, please attend morning tutorials.